Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We started discussing the solutions of the problems that appeared in the CSIR National Eligibility Test held on February 28, 2025. In this video, we discuss the solution of a problem from the section Complex Analysis. This problem is placed in Part B, which is a multiple choice question. It carries 3 marks. The question ID is 704113. This question is suitable for all these examinations. Right. This question is about the partial derivative of the real part of a given function f of z. Let f be a function from the complex plane C to itself defined by f of z is equal to e power cos of 1 plus I multiplied by sin z in the power only. For z is equal to x plus iy belongs to C, write f of z as uxy plus ivxy, where u and v are real valued functions. Which of the following is the value of del u by del x at 0, 0? We are given 4 options. These are the 4 options given to us. Let us now discuss the solution of the problem in detail. We have a function f from the complex plane to itself defined by f of z is equal to e power cos of 1 plus I multiplied by sin z. F of z is written as the real part of f of z plus I times the imaginary part of f of z, that is uxy plus ivxy. Now differentiating with respect to z, then f prime z is equal to partial derivative of u with respect to x at x comma y plus I times the partial derivative of v with respect to x at x comma y. You are familiar with this one. We have learned this when we are talking about differentiability of the complex function. So when you differentiate, you will get this one. In the process, so these are the things what you will be writing. Now you can have a glimpse of the function f z. Is an exponential function, a constant multiplied by sin z, which is an entire function which is differentiable everywhere. Therefore, its derivative exists and the u and v satisfies Cauchy-Riemann equations, and we will be using in the process of getting f prime z is equal to ux at x comma y plus ivx at x comma y. Yes. Substitute z is equal to 0. When you substitute z is equal to 0, you have to substitute the ordered pair x comma y as 0, 0. So this will imply f prime 0 is equal to ux, partial derivative with respect to x at 0, 0 plus ivx at 0, 0. This is same as del u by del x at 0, 0 plus I times del v by del x at 0, 0. Right. Now, take f of z, differentiate with respect to z. So, the derivative of the exponential is exponential itself, e power cos of 1 plus I multiplied by sin z, then multiplied by the derivative of the power. In the power, cos 1 plus I is constant, so that is constant, and the differential derivative of sin z is cos z. Agreed. Now, substitute z is equal to 0, f prime 0 is equal to e power sin 0 is 0, e power 0 is 1 into cos 1 plus I into cos 0. Cos 0 is 1, it will be cos of 1 plus I. Expand this will be cos 1 cos I minus sin 1 sin I. We recall what is cos I and sin I. We recall cos of Ix is equal to cos hyperbolic x. Sin of Ix is equal to I times sin hyperbolic of x. So, for cos I, we will be writing cos h1. For sin I, we will be writing I sin hx. Right. So, this is f prime 0. What is f prime 0 on the other hand? On the other hand, it is dou u by dou x at 0, 0 plus I times dou u by dou x at 0, 0. These two are same, equal. So, equating the real parts on both sides from these two, then del u by del x at 0, 0 is cos 1 into cos hyperbolic 1. For cos hyperbolic 1, we have written e plus e power minus 1. Cos hyperbolic 1 is e power 1 plus e power minus 1 by 2. That is e plus e power minus 1 by 2. And this 1 by 2 taken out, cos 1 by 2 into e plus 1 by e. Let's look at our options. Our answer e plus 1 by e multiplied by cos 1 by 2 appears against option 2. Therefore, option 2 is true. The answer to this question is option 2. That is the detailed discussion of the solution of the given problem from the complex analysis. I say it is a very simple and straightforward question. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We will certainly meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.